Alright, so the video to go along with the blog article. This is the C Hello World getting read, write, and execute and inline assembly introduction. So let's get started. We're going to download the source for the examples first. I demonstrate all this from Ubuntu, long-term service using only free tools. You can replicate this setup with all free software. So let's take a look at the source. And I removed the debug build from the makefile, but there's a hint in the blog article on how to add it back. Do demonstrate that both builds work. So first, let's do the make debug and turn off our output. And we can see that it loads, and the old protection, the new protection, and that's and just verifying that it was set properly. So there's that. We get some warnings about not casting things properly, but it doesn't break anything, and it's all static data that we control. So examining the source is done. Let's trace the execution into the DLL. Alright, so here we are. We can search for all intermodular calls. We're going to be loading a library. That's here. We can verify that we're at the right load library call. Get proc address, and then we're going to call the function. So we can just play. We got the breakpoint set there. We can step in. That's the preamble we were talking about. That's the 4 NOPs. So now we can come to those are the 4 NOPs right there. Alright, so this is where we're going to be placing our encoder, decoder, payload, everything. And that'll be that. So we need to make sure that we have read, write, and execute permission for this memory section. We did it with the debug build, but we can also go to non-executable modules. We can go to memory, come down to hello.dll. Text section is the 4.1 section. So if we go to CPU, well, we can see that we've got read, write, and execute. Now we go back to the CPU window, and we are in the 4.1 section. So yeah, there's that. And the program quits. So the Python script. Alright, now we've verified that we just generated this shellcode.bin file. This is the example text representation of the shellcode. That's the binary representation. Alright, now if we go and run hex edit, it's a free hex editor for Windows. We can run it inside of Wine, it works fine. And open the shellcode.bin that we just generated, we can see that the output is as we expect from here. Alright. Now we can do the object dump stuff. We've got object dump, disassemble all, binary format, architectures x86, and we want to see Intel. And you can see that it dumps this really long whatever. This is what it did look like previously. We can see the offset, the bytecode, and the instruction. Something that we're going to have to fix up is where it's got these jumps to offset. If you're doing inline assembly, at least with some assemblers, you have to use jump to label and then insert your labels. So this is the shellcode once it's cleaned up. You can see that we've got the jumps all pointing to labels. This should also be available as a download. The procedure is a little tedious, but the simplest way to do it is highlight all your jumps and then go through and fix them up one by one. The ones you don't have to fix up are ones that jump to registers. And that's the procedure for fixing that up. Then you have to strip the left-hand columns. You can do that in a little Python script too. Just take the split on either a large number of spaces or tab, I don't recall which one, and take your -1 index out of the array, and you're done. I mean, it's like 2 seconds. Anyway, and then you have to go back and forth fixing up where your jumps go. But that's all there is to that. And yep, we're done. So thank you for listening, and hope you enjoyed the article. All the code samples are there and verified working. And we'll get into the actually putting together the encoder to evade the antivirus in the third article, and we'll fix our we'll use some extended assembly so that we can do C calls from assembly, or get data in assembly and hand it back to a C call. That way we can move remove the marker function, and we can move our get, read, write, and execute inside of the payload function.